Welcome to Game Design and Analysis, Class 4, Prototyping, Playtesting, Iteration, and Scope. This lecture will be mostly slides, but I wanted to include my face a little bit so people can get a sense of who I am if you're not in the class. So let's get on with the lecture. All right, so this lecture is on prototyping, playtesting, iteration, and scope. These are all related concepts, and I want to talk a little bit about the virtuous cycle of how they're related, and then we'll go through that process in some detail. So you need to refine your game through the process of prototyping, playtesting, and iteration. But you also need to control scope throughout this process by prototyping features before you implement them. You need to limit the scope of your individual prototypes, and you need to use what you learn from your prototypes in order to continue iteration. And so I say prototype. What is a prototype? A prototype is a simple implementation of a game system or a limited set of systems created to answer a particular design question. It can be a physical or a digital implementation of your game that focuses on testability over the correctness of implementation in terms of release. What is not a prototype? A prototype is not a game jam-like fast iteration on all the ideas that you have for your game. I tell a story about a group of students that I had creating prototypes for a class at Northeastern. And one group had the game concept of, I'm going to fix all the problems that there are with Monopoly. And that's a noble goal, ambitious. There are a lot of them, but they set off to make their first prototype. And I told them, like I do, every group of students setting out, start very simple, make your prototype something you can test quickly, focus on individual design questions. And of course, as students often do, they ignored me, and they came in a week later with an incredibly detailed prototype that consisted of something as complicated as a full Monopoly board, except for inside of the ring of spaces that you move around on the outside was a second ring and a third ring and a fourth ring, each of which the player would advance through in a complicated team-based system that was beautiful to behold in their eyes. They had 45 minutes to playtest their prototype and be able to start iteration on it. And so I came back to the group 45 minutes later, and they were most of the way through explaining the rules to their game and had not begun to playtest. When I told them that they were out of time, they were shocked and sort of realized the mistake they had made, and ended up going back and creating a much simpler prototype to test the first of their ideas. So if you put all of your ideas in, it makes the game very slow to playtest. And even if they had succeeded in running their playtest and it inevitably hadn't worked the way they intended, they had added so many ideas that they wouldn't know which ones were good and which ones were bad. So you have to look at ideas one at a time in a prototype, understand what problem you're trying to solve with it, and have a way to measure the results. So you need to be careful. If you throw everything at your game like you were building a game in a game jam, then the thing that you create isn't going to produce very useful results for you. And a game prototype is not just a physical implementation of your game. So if you have an idea for a first-person tactical shooter and you build a complicated minis war game, that's not a prototype of your game that is useful to you. You've implemented a ton of different systems in various different ways in order to make them work physically, and you don't have a clear question in mind. So I wouldn't consider those things to be prototypes. Now, a note on terms. I say this to all my classes for all the different kind of terms that I throw around. Words mean a lot of different things, and smart designers often use them to mean different things. So when I define a term like prototype in this way, I'm not saying that that's the absolute true meaning of that word, or even the meaning of that word in all of game design. I'm just defining what I mean by it when I say it so that you can understand me in the lecture. Other designers, even other instructors of this course, may use the word prototype to mean something different. Don't become dogmatic about it. Use words to communicate, listen to other designers' words to understand, If they're saying something that doesn't make sense to you in terms of your understanding of the word, don't tell them they're using the wrong word, or they're using the word in the wrong way, or that you heard from Professor Barney that this word actually means a different thing. Ask them what they mean, come to understand it, and know that when they use that word, they mean something different. Someone might be using the word prototype to mean anything that isn't the final implementation of your game. They might be using prototype to mean a vertical slice of the game that you're testing at some point during your process. And those are things that are valid uses for the word. I'm trying to use it in a specific way here, and don't take it out of context or to mean more than it does. This is going to become important in a later slide where you'll see prototype used in a different way, and I didn't want to change that. So moving on. So how does a prototype help you with scope? So prototyping mechanics and systems in your game lets you understand how difficult it will be to implement that system in your final game. It's a way to reduce risk by understanding whether or not you have the skills that you need in order to create a particular game system, and let you understand how that game system is going to interact with others that you've already prototyped and added to your game. It lets you understand how much benefit you'll get from those systems. If you are adding a power-up system to a game in order to create feelings of more feelings of player autonomy, you can measure those feelings before you add the power-up, and measure feelings of autonomy afterwards, and say, yes, this did or did not have the intended effect, and then decide whether or not you actually want to add that system to your game. It can let you avoid implementing systems that only add scope without defining benefit. Very often, especially when you're working on a group of designers, someone will think something is a beautiful mechanic to add to a game, and it's because they like that mechanic, not because it's actually contributing to the unified design of that game. And it'll let you find real answers rather than having endless debates. Often you'll have a disagreement with another designer, and neither of you can prove through argument that you're right. Stop arguing, build a prototype, test the idea, and have a real concrete answer, and be willing to accept it when it's not the one that you're looking for. All right. So what about iteration? Iteration drives prototyping, and prototyping drives iteration, right? When you iterate, you're going to have new ideas based on the results of when you have an idea that you want to iterate on, you need to build a prototype around it in order to test whether or not that's a good idea or a bad idea. Otherwise, you would just be building the game and releasing it, right? So you need to build prototypes to test for each iteration, and each prototype's results, right? The outcome of the playtesting of a prototype is going to give you new ideas that you want to add to the game. So that's important. You're going to revise your design after each round of prototyping and playtesting, depending on what you find out, what answers the prototyping and playtesting provides you with. You're going to limit the implementation to aspects of the game that are validated through prototyping. So don't add it to your final game design until you've tested it and you understand how it's going to interact with your other systems, how it's going to work. Each iteration is going to raise new questions, and you're going to create new prototypes to answer them. The danger of iteration is that it can go on forever and ever and ever, just leading to more and more features and scope creep to your game. And so you need to be doing the play testing and building prototypes to determine whether or not features should be added, and to keep your scope defined as you go forward. And with each iteration, add to the concept of your game. You need to let it not get away from you. Prototyping, validating concepts is a good way to do that. So playtesting. How is playtesting different from prototyping? I said, you sort of need to do both of these things together. You do playtest some of your prototypes. You might build a prototype that is, does my jumping system allow me to get over the, gaps of this width? You can determine that mechanically. You're not going to playtest it. It's going to sort of prove itself by implementing that mechanic. But you do have to playtest a lot of your prototypes. You're going to build it. You may playtest it yourself. You may playtest it with other members of your team. with strangers, with people from your target audience, but lots of your prototypes will be play tested. Many of them are going to be small systems that aren't even really a game in and of themselves, but watching the results of using the prototype will allow you to answer your question. And you're also going to play test your final game as you are building it throughout the process. Like, as soon as you start implementing your game, you're going to be testing those systems yourself as you implement them. You're going to be testing them with team members. When you have chunks of gameplay that are substantial, you're going to be instrumenting your final game and playtesting it with people. Now, those aren't prototypes of your game. Those are your actual game at different stages of implementation. So you playtest prototypes, but you also playtest your game. That playtesting can be formal or informal, right? It can be you trying it yourself and seeing if it works, trying it with your team members, with a friend. But it can also be formal, where you've come up with a specific set of questions that you're going to ask somebody in order to help you understand whether or not your prototype has succeeded or failed. And that process can have a very defined structure. We'll talk a little bit more about research methods at the end of the lecture. Playtesting can be internal or external. Earlier on in your process, you're going to tend to playtest with yourself and internally to your team or your studio. Later on, you're going to be seeking playtesters that know less and less about the game and are closer and closer to your target audience. You need to instrument your game in order to help you prototype and answer questions. By instrument your game, I mean define ways that you can measure player behavior and actions in your game, and that you can then use later to analyze and understand how your playtest went in a not subjective way. So, for example, does increasing movement speed in my game increase player feelings of autonomy? Might be a question I have. So I'm going to build a prototype that will let me test feelings of player autonomy. It might just be an early build of my game. It might be a physical paper prototype of the game. I'm going to, with the sort of movement as I have it, I'm going to measure player feelings of autonomy through surveys and questions that I'll build. So again, we'll talk about those in a bit. And then I'm going to build a prototype of the game that has the increased movement. And then I'm going to measure that to determine players' feelings of autonomy. In that version, did those feelings increase when I increased movement speed? Yes or no? I have a definitive answer. As an aside, playtesting and QA aren't necessarily the same thing. Playtesting is trying to answer a specific question. QA stands for quality assurance. And while the QA department is often doing playtesting for you and with you, quality assurance is often a much more defined process where specific behaviors your game is supposed to have, and you are playing each build of the game to assure that those behaviors have been implemented correctly and that there hasn't been a regression or something you've added to the game hasn't made those behaviors no longer be true. So that process can be quite formal. The larger your game studio, the more formal a QA process you're likely to have. And having that kind of a QA process implemented early in the development cycle is very important to producing a game that's not full of lots of bugs. So they are two different things. They sort of exist on a spectrum, from very informal playtesting through very formal and rigid scripts for testing quality assurance. So iteration, you can iterate at every stage of your design. Don't wait until you're creating playable prototypes to start that process. You want to, test your core mechanic even when that's not a game, right? If your core mechanic is moving and attacking, build a paper prototype where you're simulating the kind of movement and attacking you're doing. Does that go? Does that work? Each feature you add to the game, you want to build prototypes of. You may not even have a full game design, right? You have an idea for how something might work, build a prototype, see if that is indeed what you want. If it's not, go somewhere else, eventually settling on what you want your core gameplay loop to be after having done testing. So you can prototype on, hour one, minute one of your ideation process, start building prototypes and testing things. Don't wait until you have built a vertical slice of your game in Engine to see whether or not it's enjoyable, whether or not it is creating the experience that you're trying to create. Your design is created through iteration. So you want your design document itself. So you want to version that design document if you're producing, rewriting it over and over again. Often design logs are a really useful way to go through that process. You write out your initial design, and then you have entries in the bottom of your design document for each playtesting session, for the iterative changes you want to make based on that, for the design of the prototype that you want to use to test those iterative changes, and then for the playtesting of that prototype, repeat until you've finished building your game. Yeah, so you don't just want to constantly edit your design document ad hoc without keeping track of what changes you're making. It's hard to know what the progress of your development cycle has been without that, and it's hard to roll back changes to a past point if they don't work out as you go down the line. You want to iterate with your prototypes. So within an individual prototype, did the prototype answer the question you created it to answer? If it didn't, you need to alter the prototype. You need to add in more instrumentation to it. You need to test it with another group of users. And so you may be playtesting with an individual prototype many times as you refine and try to seek the answer to a particular question. And then for each kind of prototype you build, can that prototype be used to answer other questions? You put the effort into building it. Can you do other things with it that will allow you to answer other questions you have before moving forward with the next iteration of your game? Get all the use you can out of a prototype, but don't try to do it all in a single playtest. Don't try to do it all in a single version of that prototype. You want to be specific with each one that you build. Okay, so how to build a good prototype. So you want to pick a question for your prototype. You don't just want to build an implementation of your game and play test it and see what happens. You want to have a question you're trying to build the prototype to focus on. Don't just start building your game. So you do want to start with a single mechanic or simple system that you want to prototype. You don't want to implement a full vertical slice of your game, or worse yet, the whole game, and call it a prototype and see if it works. You're going to have, if you need to strip back a lot of the effort you made, that effort's just going to be wasted. And you will need to make basic changes to the game that mean that a full implementation or a vertical slice is going to be a huge waste of your time. So you do want to play with the same people multiple times through different playtests, but you don't want to always play with the same playtesters. The playtesters will get more and more experience with your game. They'll have a learning curve. You do want to see that. But if you always playtest with the same playtesters, then you're going to have playtesters who have learned what's wrong with your game and how to work around it. And they're going to stop complaining about the problems that new playtesters will be tripped up by. You do want to playtest with different people because all playtesters aren't created the same. You want to playtest with as wide a variety of different people as possible, starting with yourself and your team, and working outward as you become more confident in your prototypes. You don't want to never use the same playtesters, right? You don't want to, every playtest is with a different group of people, because one group of people happened to have people that like strategy games in it, and another group happened to have people that hate strategy games. You end up adding strategy game elements after one playtest, and then removing them after the next playtest. And actually, that isn't warranted. It was just that your playtesters were two different groups, right? So vary up whether or not you're using the same or different groups of playtesters. Let's see. You do want to only make one change with each prototype. You don't want to make as many cool changes as you can to your prototype based on a particular playtest, because then you're not going to know whether changes work or not, right? If all the cool ideas that a playtest gives you, if you just add all of them, make all of those changes because every single one's going to make the game better, you're wrong. And you're not going to know which ones did and which ones didn't because you threw them in all at once. You really just want to try to add one at a time. It's hard. Developing that discipline is going to save you time in the long term. Cramming 10 changes into one playtest does not save you 9 playtests. It just means you have to do 11 because you don't get the answers from the first one, and then you still have to do the 10. Let's see. You do want to have, so you need to decide what you're measuring in your playtest and how you're measuring it. You need to implement the playtest. What are you counting? What are you watching for when you're playtesting? If it's digital, you may be implementing some kind of logging system. If it's a physical prototype, you may be sitting there with a notebook, keeping track of how many turns people took, how many dice rolls they made, how many points of damage they did. You need to track all of those things very specifically. You don't want to spend a lot of time making sure that your prototype looks good so that playtesters can appreciate it. I'll show you a slide in just a minute, which is going to be about that problem. You want to have both defined and open questions for your playtesters. Don't just ask them, on a scale of 1 to 10, rate this for everything. You want to leave them a chance to provide you with open information, but you don't just want to give describe your experience with the game kind of questions, because those are very hard to code in a way that you can analyze with any kind of specificity. You do want to create prototypes as quickly as possible. You don't want to spend a ton of time building each one. You want to build it as minimally as possible and test it. You don't want to keep good prototypes that worked out really well and just graft them onto your final implementation of the game. You do want to throw away and never build a final game based off of your prototypes. It's always better to start your coding over again at the beginning, build up from there, and redo the work without making the mistakes you were making when you were implementing the prototype. You do want to listen to what your playtesters think is wrong with the game. If they sense a problem with the game, they're probably right. There is a problem with your baby that you need to take seriously. You don't want to listen to how your playtesters think you should fix that problem. Record it, think about it, but don't just say, if they say, there's something wrong with the shooting mechanics here, I need bigger guns. Don't just go implement bigger guns. You want to think about what's the problem that they're sensing and dig into that. Oh, they're feeling like they're kind of powerless. They're feeling that they're not being effective when they're shooting the enemies. That could be because the enemies have way too much health and are bullet sponges, and you need to make them more fragile. It could be because your hitbox system isn't great and a lot of the bullets are not actually striking them, and you need to refine that system, right? It might be because your guns aren't powerful enough and you need to turn them up, but that's only one of many different possibilities, and those aren't going to be visible to your playtesters. So listen to what they think is wrong. Don't listen to their solutions as seriously. Okay, moving on. So here's just a quick example of some examples of good and bad prototypes from a game that I made. Quick story is that I was in the developers program for Google Glass. I thought it could be a really awesome thing. I came up with a game idea for it that was a ingress or territory control kind of game system on a smaller scale that would be played within a university where individuals or small location where individuals would set their own control points and place guards on them and then run around the campus attacking other people's bases and that kind of thing using the Google Glass system. So I had like 6 months from when I was approved to when I actually got my hardware. And I thought, well, I should playtest this in some way and create prototypes. So I thought, well, I'll make a board game implementation that tests simultaneous movement. The process that I did for that wasn't great, but it determined that it was a really compelling mechanic, although my early implementation was in no way fun. No one blinked for the 10 minutes of the playtest. They were all dripping in sweat by the end of it because it was so intense, and none of them had a good time. But I thought it was worth pursuing. Then my Google Glass arrived. I wore it around Boston a little bit. Everybody looked at me like I had two heads. I realized the technology was not going to be accepted regularly and that there was no point in going forward. But the mechanic was interesting enough. I decided to make a board game out of it. My second iteration, moving towards a board game, I made a classic blunder, which is that I decided on a theme and created this, to me at the time, beautiful second diagram here. with a lot of intricate detail and specificity. I was falling into the trap of adding a lot of different game systems, figuring out how it would all work, building an entire playable game and a beautiful prototype. About 5 minutes into the playtest for that prototype, I realized that both the map had serious problems and the basic gameplay systems that I had designed weren't going to work out. I wasted a week building that prototype and detailing it with my wonderful art style there. The game ended up changing pretty radically and not having a defined game board at all. Placing paths, as you can see in the animated diagram, became a major part of the game. That prototype, while somewhat time consuming, I used for a long time as I iterated on what shapes the paths should be and how it should be used. I was able to build and iterate on it pretty well. And then eventually, I ended up adding theme and more structure to the game, and ended up with the last picture you see there, which doesn't even have hexes on it and is played on a post-apocalyptic canvas. So the first prototype was good. The third prototype was pretty good. The second one was terrible. It was making all the mistakes I'm trying to tell you to avoid. Over time, I eventually ended up with that final system. So how does this relate to this class and what you're all doing now? The project that you're doing over the course of the semester with your groups, you can sort of break that up into 5 parts, and prototyping and iteration and playtesting should be used at all the stages. Initially, you were looking at, should be a couple of weeks ago now, narrowing the scope of your game to a basic core mechanic. You would want to build a prototype of that core mechanic, see if it worked. It's not too late to do that now. Test that core mechanic. Does it function before building on top of it? When you're looking at the other features you want to add, deciding how much you can add during the course of the semester, playtest adding each of those features in a prototype before you think about actually implementing it into the final game. And then also you'll note that in the descriptions of the assignments, it allows for resubmission. So your submission process is also iterative. We're all, as instructors, going to grade your first submissions pretty strictly, knowing that you can revise and make improvements, right? We're going to give you feedback so that you can help make your game better, knowing that that's not your final grade. You're going to be able to resubmit and make it better. Even the assignment process here is iterative. In the documentation phase, each thing that you add to the documentation should be something that you're playtesting, right? We're adding this feature. We're going to playtest, build a prototype, playtest that feature, decide if it functions or not, and then document the success or failure of that. 4 through 6 sections are about building the prototype for your game. And this is where I said there was a different use of the word prototype, right? And here we're using prototype to mean a early version of your game that you're going to continue to revise, and that's going to sort of validate that your game overall functions as a game, so that your second half of the class can be iterative improvement there. This prototype should not be the first prototype you build, should not be the only prototype that you build. This is a vertical slice of the game that you may throw away if it doesn't work well. It's a playable demo of the game as it stands so far. And so here we're saying that is the prototype. That's how it's referred to in the documentation that we've given you for the course, but it is one of many prototypes, and it's the first prototype that's going to test all of your game systems that are combined. So you're working towards that week 6 submission of a vertical slice of your game that shows that it is fully functional. That should have been built after the many different prototypes and playtesting of them in the iterative process building up to there. And we'll do a assignment today in class and exercise that will exercise your skills at doing that kind of rapid iteration. And then from week 7 to 9, you're going to be doing playtesting and iteration of that whole system, refining it. If you're deciding to add a new mechanic, you maybe will want to build a small prototype of that mechanic and test it, and then integrate that now proven to be functional mechanic into the larger game to see if it it fixes the game or improves it in the ways that you were intending. And then again, for your final submission, you're going to have a week after that final submission to revise. So we're going to look at it. We're going to grade it seriously and rigorously, and give you a chance to improve on the thing that you submit. So every step of this process is iterative. Every step of this process involves building prototypes and testing them. Cool. Rigorous academic research methodologies. There is a whole class that digs into this, GSND 5130, which is called Mixed Research Methods for Games. This class looks at formal research techniques and how they can be applied to different games. When I say instrumenting your game, it looks at what kind of things can you record, right? In digital versions of your game, what kind of things can you record and how to do that in a way that will produce data that is easy to statistically analyze. Here are a few things you can think about sort of in common sense ways that will help move you in that direction, help make the data that you have for this class and for other games that you're doing less formally move in the direction of being that kind of formal work. So sample size. If you end up working on a thesis project that involves doing research and drawing conclusions from it, you're going to need a reasonable sample size. Now, you can statistically draw some useful information from a relatively small sample size through some clever statistical analysis. However, the larger your sample size, the better off you are in terms of coming up with a meaningful statistical analysis. So you need more than 2 or 5 or 7 people for most kinds of statistical analysis. And you need to start early and figure out where those people are coming from. Surveys. So you don't want to use leading questions in surveys because they're going to heavily weight the answers people give you. And you need to consider how well the people you're surveying know you and whether or not they're answering in ways that are just intended to please you. A great survey given to your mom is going to produce data that's not terribly valuable to you, right? Or your roommate or whatever. So another thing is you want to ask questions that can generate numbers. A way that you can do that with somewhat qualitative sounding questions is by using a Likert scale, which is the, I strongly agree with something, I agree with it, I neither agree or disagree, I disagree or I strongly disagree. That gives you a 5-point spread. You can analyze what that spread is over the course of a bunch of different playtesters, and then how that spread changes over different iterations of your game. And that provides a useful set of data for you. So that's good. Drawing conclusions versus statistical analysis. What I said about sample size and you needing a lot for most kinds of good statistical analysis. That's true, but that doesn't mean that you can't draw useful conclusions from only a few playtesters. 3 or 4 playtesters having a strong and similar reaction to the game may be enough to let you know that you really need to address a particular aspect of the game. So you're able to draw conclusions usefully even from small sample sets, but be careful, because if your small sample set is in an extreme edge of your player base, those answers may be misleading. You want to gather context on your playtesters because they're not all the same, right? If you have a bunch of people who don't like first-person shooters testing your first-person shooter, then they're probably not going to like it very well, and it may not be because your game is bad. You want to get their opinions, but you also want to understand that they don't like the kind of game that they're playtesting, or that they really like the kind of game that they're playtesting, and so they'll love whatever you do. You want to know their demographic background so that you can track that across all of your playtests and understand it. So those are things you need to consider. Hope this lecture has been useful to you, and I will talk to you all again on next week's lecture. Have a good day.